Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining trunks. So far in our discussion of VLANs, we've talked about how switches can have different ports assigned to different VLANs, thus creating virtual segmentation within a network. But what happens if we want to connect two switches together? Let's say we have these two switches here, and on these ports we have VLAN 10, on these we have VLAN 20, and on these we have VLAN 30. How do we interconnect these switches so that the logical separation of these VLANs can be extended to both switches? Well, one way is to create 3 ports on switch 1, each one on VLAN 10, 20, and 30 respectively. Create something similar on the other switch and then connect them. That way the broadcast domain would logically be separate on both switches, being served by one physical link each. So layer 2 communication could still take place between two devices on the same VLAN on different switches. But let's say we have 10 VLANs and 7 switches. Such a combination would quickly become too complex to manage. You would have to make sure that there's a physical link between each physical switch on every VLAN, so that layer 2 communication on a particular network segment would be possible. Let's move this to the extreme. Let's say that you have 250 VLANs and 75 switches. Well, you get the picture. It becomes unwieldy and unmanageable. There must be another way to deal with this kind of network topology, and there is. That's where trunk links come in. Trunks are physical links between switches that can carry multiple VLANs. Trunks eliminate the need for a single link between switches to serve each VLAN. Trunks are able to keep frames from different VLANs separate on the link due to what is known as the 802.1q tag. This is a standardized piece of additional information that's added to the Ethernet frame header to identify to which VLAN that particular frame belongs. Let's take a look at this topology here. We have 2 VLANs configured on both of these switches, and we have a single link between them. If we configure this link as a trunk and specify that we allow VLANs 10 and 20 to use it, then any frames from this host destined to this host will be sent over the trunk. Specifically, if this host sends a frame to this host, the frame reaches this egress port, which is configured as a trunk port. The 802.1q tag is added to the frame, indicating it belongs to VLAN 20. It is sent across the trunk and it is received by the other switch. That switch reads the tag, sees that it belongs to VLAN 20, strips the tag, and forwards it appropriately. So these 802.1q tags exist on a frame only while the frame traverses the trunk. It's also important to note that these tags add additional overhead to the Ethernet frame, making the header 4 bytes longer. Now, before I continue, I'd just like to say that this video is sponsored by XOP Networks, provider of emergency communications phone systems for airports, power plants, and disaster relief organizations. Learn more at www.everythingoverpackets.com. Now, there are a couple of questions that need clearing up. First of all, if this host sends a frame to this host, how does the switch know to send it over the trunk? Remember the MAC address table? When communication takes place, the MAC address table is populated. This is what the MAC address table looks like on this switch. You can see that the MAC addresses of all these hosts here appear on this single interface because they were detected as source MAC addresses on frames that entered that port. But you can also see the VLAN to which each one belongs. So trunk ports will typically have many MAC addresses corresponding to their port in the MAC address table, along with the VLAN they belong to. Of course, if the MAC address table doesn't have an entry, the frame will be sent out of all ports assigned to that VLAN, including the trunk, assuming the trunk includes that particular VLAN in its configuration. So such a frame would reach all hosts within the VLAN on both switches. Now, trunks must be configured carefully. Both ends must be configured as trunks, must have the same allowed VLANs, and must also have the same configured native VLAN. I won't go into the native VLAN here, we'll do that in an upcoming video. But keep in mind that the native VLAN must be the same on both ends. Now I'd like to share a little bit more with you about this 802.1q tag. Now the name sounds weird, but it is the IEEE code that is given to the standard. This tag has several components to it. These fields here are used for applying quality of service mechanisms on the trunk, so that the appropriate priorities are given to frames that contain time-sensitive payloads like voice over IP, for example. Because trunks can potentially become bottlenecks in a network when you have many VLANs attempting to send info across them, QoS mechanisms exist that can prioritize frames on the trunk based on these parameters here. The parameter, however, that specifies the VLAN to which the frame belongs is this 12-bit VLAN ID. Now let me stress here that hosts like these devices connect to what are known as access ports. These ports are assigned a single VLAN, and that VLAN should correspond with the IP addressing subnet that you have defined for it. Hosts on access ports belong to the VLANs configured on those ports. Trunk ports are almost always connected to another network device such as a switch. Now, because of this distinction, hosts on access ports will never see frames with 802.1q tags on them. And indeed, they shouldn't. If they do, then there's something wrong with the configuration of the switch to which they are connected. Well, that's it for trunks. If you like my teaching style so far and these are topics that you're interested in, check out my Mastering VLANs and Trunking course on my website. It goes into much more detail than this YouTube playlist and includes labs, configurations, PDF notes, quizzes, and a final exam, all of which will help you to master the concepts of Layer 2 switching. Check it out now at my website at www.telecomtech.io. You can click on the link in the description below to get there. More courses on additional topics are coming soon, so stay tuned. Check it out and join my newsletter to be the first to know about new content along with some exclusive offers along the way. I'm Lazarus at telecomTech. I hope this has been helpful for you and I'd like to thank you for watching.